about the mean and standard deviation of a random variable. So the first things first, put the date on here above the definition for parameter. We've talked about parameters before, but I'm going to keep saying it because it is really important. If we have a parameter, that's a value that tells us something about the population. And so sometimes what I think is helpful is think back to like your English classes and you had to do those like comparisons. I don't remember exactly what they're called, but you have to make comparisons between certain things. So in this case, I'll put one on here. So I'm going to say parameter is to population as statistic is to sample. And that's one of the notations that you've used. So it's kind of like a ratio, but with words. So a parameter is to a population as a statistic is to a sample. If I have a value that's a statistic, that's coming from a sample. If I have a value that's a parameter, that's coming from a population. Okay, so let's put the definition for the mean of a random variable. Another word that you'll hear me use is expected value. Actually, that's the more common word that we'll use is an expected value of a random variable, but it's the same thing as the mean. And what you're going to do is it's just like a regular mean where you take the average of all your values, but this time we're going to account for the fact that each option is not equally likely to happen. Some options are more likely than others. What do I expect to happen, expected value, if one option is maybe more likely than others? And so what you're going to do to find an expected value is, well, let's put the notation on there. So we have mu, we've seen mu before, and I'm going to actually put mu sub x. If x is my random variable here, I like to say mu sub x. That's the same thing as e of x, expected value of x. And so what you're going to do is you're going to take each value, all the x values, so this would be like x1, and you're going to multiply by its probability, probability 1. Then you're going to add to that the second option for x times that one's probability, etc., all the way down the line until you've added all of the x values multiplied by their probability. So this would be like a summation, every x value times its corresponding probability. This is the formula, but really what you're doing in words is you're multiplying each value by its probability and adding them together. Let's go ahead and use this. I want you to read example 22. It's pretty long. It talks about a roulette wheel and kind of what is happening here. And then you'll see a little chart down there at the bottom. So take a second, pause the video, and read the explanation as to what's happening here. Okay, so my random variable x is the net gain from a single $1 bet. So if you bet $1, you're going to lose $1 if it doesn't land on what you've betted on. If, however, it lands on red, then you will gain $1. So your net gain is $1 because yeah. Okay, so there's our two options for our probabilities there. And I want to know what's the player's average gain because each of these is not equally likely. So the average gain is not 0 because you are actually more likely to lose money than you are to gain money. So let's go ahead and put this into our formula. So we have mu of x or e of x, either notation is fine, and that's equal to the value times its probability. So this would be -1 times 20 over 38 plus +1 times 18 out of 38. And if we add those together, we should get -5 cents. This is telling me that on average, in the long run, I can expect to lose 5 cents by playing this game. Of course, sometimes you'll be out on top, sometimes you'll be out on the bottom, but when it averages out, think law of large numbers, when things start to average out, it should average out to about -5 cents. So let's put what this means in words. Again, kind of summarizing a nice little crisp sentence at the end of our problem here. After many plays of the game, the player can expect to lose since it's a negative value, the player is expecting to lose an average of 5 cents per $1 bet. That's what the expected value means. That is the mean of a random variable. Let's talk about standard deviation. Now, we can't talk about standard deviation unless we first talk about variance. And variance, remember, it's that long, complicated formula. We take the square root at the end to find our standard deviation. So the variance of x equals, another notation is sigma squared, and I'm going to put the x, kind of like I put mu sub x, I'll put sigma squared sub x, so I know which random variable I'm talking about. And what we're going to do here is we're going to sum all the x values minus the expected value, the mean there. We're going to square them. This is the same formula that we used way back when we first learned about standard deviation, but now I'm going to multiply each one by their probabilities. This is not something you have to do by hand. However, you do need to show the work, but then you can type everything into your calculator and have your calculator do all of the calculations for you. Standard deviation always is the square root of your variance. And so let's just put a big square root over our summation formula. If I can write down u squared times the probability of I. And then just another reminder, like I said, we're going to talk about symbols kind of a lot here. So if I have a population and I want to find a mean, these are my parameters, anything that's here on a population. The mean is mu sub x, and the standard deviation is sigma sub x. If I'm coming from a sample, the mean is x bar, and the standard deviation is SD. Okay, just the notations are going to be really important next chapter, and so I just want to really get this in your head and talk about it now so that it doesn't come as a shock next semester. Okay, or next chapter. I'm sorry, next chapter. So let's calculate these values. So we're going to use the APGAR score data that we talked about in class when we talked about the discrete random variables, and so that's going to be just a couple pages back from here. That's going to be on page 19 if you want to go back and look there. I want to compute the expected score and the standard deviation of the scores, and then we'll go ahead and interpret them. Okay, so I'll do the first one together, and then I'll let you do the second one down there where it says try it. So first thing I'm going to do is I'm going to find the expected value of x. And to find the expected value, we multiply all of the numbers times their probability. So it would be 0 times 0.001, 1 times 0.006, plus ... all the way to the end. There's a lot of values here. You don't have to show your work for all of them, because ultimately what you're going to do is just type this in your calculator, and you don't have to write down every step of the way, but you do have to show enough that the reader who's looking at this can say, all right, this person knows what they're doing. They can show me how they found these values. Okay, so go ahead and type this in, calculate it by hand, and then actually when you get back to class, I will show you a shortcut about how to get the expected value with the probabilities there. But for now, just go ahead and multiply those out, and let's see what we get. And I got 8.13. Again, this is enough work to show for the expected value. The interpretation of the expected value is the expected APGAR score. And I don't know why I capitalized expected here. We don't really need to do that. And this is the expected score for a randomly chosen baby. And that is 8.13. And I don't have units. I don't think we have units. If I did have units, I would want to put them there, whatever the context of it, just points maybe or the score. Alrighty, now for the standard deviation, you are going to take, so let's calculate the variance first. And so what we're going to do for the variance is we're going to take each value. So like the first value is 0, minus the mean, which is our expected value, squared, times the probability that that occurs. And I'm going to, so that's 1, I got to show another one. So I'll take my next value as a score of 1, times the probability that 1 occurs, plus ... and all the way to the end. Okay, so again, go ahead and calculate this for now, and then I'll show you the shortcut when we get back to class. And I got 2.0736. Now this is the variance, it's not the standard deviation. The standard deviation is just the square root of that number, which is 1.44. And let's go ahead and interpret it. So this is, we'll use the same general interpretation that we've used for standard deviation in the past. So what I'm going to say for this is a randomly selected baby. And I'm going to say a baby's APGAR score, to put the context in there, will, on average, differ from the mean. And the mean here is 8.13 by 1.44. And then maybe it's points. Again, I don't really know the context. Maybe I'll just say units. Or maybe points is a better word there. But that's how much on average it's going to differ. Okay. Now this was a lot of typing and calculating. And again, I am going to show you kind of the shortcut there. So what I'd like you to do next is I'd like you to look at this next example. And there is some space on the next page if you want to answer part B on the next page. There's a lot less points here for you to calculate. And showing adequate work would be, well, actually for the mean of this one, I did go ahead and show all 4 things that I added because it's really not that much. And actually you probably could for standard deviation as well, but as long as you've got 2, maybe 3 points, just like I had up above, that is adequate work. Okay, so go ahead and pause the video. You'll have to answer some Edpuzzle questions, and then I'll put my work here so you can check yours with mine when you're done. All right, so you can see my answers there on the screen, and you can check yours against mine.